So, starting with this, I just took questions off of the game we played, the ones we didn't get to, like this. It says tell how many common tangents the circles have and then draw them. What is a tangent, first off?
It's
a line that touches the circle once. So we're trying to find a common tangent that touches each circle one time. There are two types of common tangents. What are they called?
External.
Yeah, external and internal. How many external tangents are there?
Two.
There's going to be two. If I could draw them. There's one. There's two. And then how many internal will there be? Two. And what would they look like? Like an X, yeah. Just pretend that they only touched once and that it was prettier than this. But here you go. What if two circles...
Can I just go over here and grade them?
That's fine. What if two circles touch at one place? So again, pretend that they touch in one place. How many external would they have?
Two.
Still two. All right, 1, 2. How many internal would they have? 1. And it would be where the two touch, right? What if you had, just pretend that that's a circle. We all know that's an oval, but I'm just doing my best out here. What if we had one circle inside of another?
0.
It'd be 0. Because anytime you try to draw a line, it may touch the inner circle once, but how many times would it touch the outer circle? Twice. Which would make it what kind of line? A secant, which is not a common tangent. So this would have 0 internal, 0 external. It wouldn't be anything. All right, something else on your quiz. Tell whether the red arcs are congruent. Explain why or why not. 2 things make arcs congruent. Can someone tell me one of them?
radii or
Yeah, so congruent radii, or it's in the... Nope, it's the second one. I'm still on the first one. They're congruent radii, or the 2 arcs are on the same circle. Okay, so they're either in the same circle or they have congruent radii, which means they have congruent circles. And then the second thing does deal with the central angles. What do the central angles have to be? Correct. Central angles would be congruent. So looking at this picture, we're trying to figure out if AB and EF are congruent to each other. Let's look at where AB is. What is the radius of the circle I've highlighted? It is 6, right? It's CD. Right? CD. What about for the other circle?
6.
It is also 6. So do they have the same radius?
Yes.
They do. They weren't in the same circle, but they have the same radius. And then are their central angles congruent? Yes, 95 and 95. So are these 2 circles congruent? Yes, and you would tell me the reason. Okay? All right. This says find the value of x. It should be an r. And what would be important here is that AD is tangent to the circle. So what did we learn about tangent lines and circles? Yes, they only touch once. This is from 10.1. That they're what? We will have to do the Pythagorean theorem, but that's not what I'm looking for. So what does the tangent have to be? It has to be something, and you wrote it down. Why do we use the Pythagorean theorem? There's no...
Is it perpendicular?
Has to be perpendicular
Yes.
to what?
The
So this is my tangent line, right? AD is my tangent line. What does the tangent line have to be perpendicular to? The radius. So my right angle would be here at D. So on your quiz, there will be one like this, but there will also be a question that says, is the line tangent? So whenever you say, is the line tangent, what do you have to do to figure out if it is tangent?
solve.
Take out your 10.1 notes. Every single one of you. 10.1. 10.1, just 10.1, page 2, example 2. Example 3 at the bottom. It says, is ST, right, is ST tangent to circle P? In order for a tangent line to be tangent, what does it have to be? Perpendicular to the radius. So what do we do to figure out if the tangent line is perpendicular to the radius? The Pythagorean theorem. A squared plus B squared equals C squared. If it does equal, then what is your answer?
Yeah.
Yes. And if it said explain, what do you write down? The tangent and the radius are perpendicular to each other. If they don't equal, then you say no, because the tangent and the radius are not perpendicular to each other. Okay, perfect. So that brings us here on a different type of problem. Okay? AD, we know it's tangent to circle R, it would tell you, or to circle C, sorry. It says to find the radius. So we're still going to use the Pythagorean theorem, but we are missing something and we are going to solve for it. Which of these sides is C? 6 plus R. It is always across from the right angle, so it's going to be 6 plus R squared, and then that means A and B are going to be 12 and R. What is 12 squared? 144 plus R squared. And then what do I do with the 6 plus R squared?
So 6 times 6 plus R.
6 plus R times 6 plus R. And then we distribute using FOIL. How many terms will I get if I distribute correctly? 4 different terms. Because FOILing is just multiplying 6 times both of these, and then it's multiplying R times both of these. Okay, so let's start with 6. 6 times 6 is 36. 6 times R is 6R. R times 6 is 6R, and then R times R is R squared. Yep, what happens when we subtract the R squared? It cancels on both sides. I'm going to drop down the 144 equals 36. What is 6R plus 6R? 12R. And then my next step, subtract 36. What is 144 minus 36?
Wait, what?
144 minus, it is 108 equals 12R divided by 12, and the radius is 9. So you will have a question like this on the quiz. Do we have any questions?
So that's all you have to do?
Yes.
Okay.
So notice how I had 1, 2, 3, 4. Look, 1, 2, 3, 4 terms. If you don't have 4 terms, then you did not multiply correctly. All right, another find arc AB. What do we notice in this picture?
That the two
Yeah, the 2 tick marks, right? So we have 2 congruent chords, which means we have 2 congruent arcs. What 2 arcs are going to be the same measure? ED and AB. They're going to be the same. So if we want to find AB, what is ED? 61. So that means AB is also 61. Why didn't we double it? What kind of angle is this? It's a central angle because where's the vertex?
in the center.
On the center. Okay, so all of these angles have the vertex on the center. Whereas here we have inscribed. Okay, so inscribed, the vertex is on the on the side. Yeah, on the side of the circle. So if we want to find angle T, which is the first one, what is the name? I'm not looking for a number. What is the name of the intercepted arc for angle T? RS. What is the relationship between the intercepted arc and the inscribed angle? Yeah, the arc is double the angle. So what do I do to find the angle? Divide by 2 and I get 24. The second question asks for QR. Is QR an intercepted arc? It's not. An intercepted arc is the arc between the 2 rays of an angle. So if you look at 50, what is 50's intercepted arc? It's a Q, but it's okay. QT, TQ, however you want to say it. It's this one. So what's the measure of the intercepted arc? 100. But that is not the measure of QR. So what in this picture is important to notice? I do see the chord at the bottom, but that's not going to help me here. The diameter is helpful because what does a diameter do to the circle? Cuts it in half. So that means this circle has been cut in half. So how many degrees is in the top half? 180. So what's the measure of QR? 80. You do have a question exactly like this on the quiz. The numbers will change. They're very similar. The last thing we do are these. These are inscribed. They're inside of a circle. What kind of shape do we have in A? It is a right triangle. Why do I know it's a right triangle? The hypotenuse is the diameter. Good. So where's the right angle? At 2x, at C. So what do I do to find x? 2x equals 90. So then x would equal 45. Whereas B, what shape do we have there? Quadrilateral. What is the rule we learned about inscribed quadrilaterals? Opposite angles are supplementary. So what's opposite of Z? 80. So what's Z going to be? 100. And then what's opposite of Y? 120. So that means Y would be 60. Good. Go ahead and clear your desk.